Welcome back. So, um, what we want to do now is uh, look at the vertical asymptotes of a rational function. So remember, a rational function is a quotient or a ratio of two polynomials. So suppose that f of x is a rational function where the numerator is n of x and the denominator is d of x. N and d, they are polynomials. Let's say it is in reduced form. So what do I mean by reduced? It means that the numerator and the denominator have no common factors. So that is, you have factored the numerator and the denominator as much as possible, and you have canceled the common factors. So if f is reduced, and if the denominator vanishes at some number c, that is, if the denominator is 0 at some number at some input c, then the line x is equal to c would be a vertical asymptote of the graph of the function f. So consider the function 4 times x minus 3 over x squared minus 4x plus 3. Now, before we try to find the vertical asymptotes, the first step is to make sure that f is in reduced form. Now, how do I check that? Well, let's factor out the numerator and the denominator. And so so if I factor out the numerator and the denominator, then we see that x minus 3 is a common factor. So we should cancel that out, and then we get 4 over x minus 1. Now, if we don't do this step right here, then we will be getting a wrong answer if we apply the fact that I presented here. If the denominator vanishes at 0, then if the denominator vanishes at c, then x is equal to c is a vertical asymptote. If I use this fact without reducing, then for this function, we will say, well, x is equal to 3 is a vertical asymptote, and x is equal to 1 is a vertical asymptote. But x is equal to 3 is not a vertical asymptote. So the fact that you can cancel out these two factors, it means that so right now it means that this function f is the same as the function 4 over x minus 1. So these two functions, the 4 over x minus 1 and f, they are the same as long as x is not 3. So except at x is equal to 3, these two functions are the same. So that means that the graph of f is the same as the graph of 4 over x minus 1, except that the graph of f has a hole when x is 3. So obviously the function 4 over x minus 1 is defined at 3. And so when you draw the graph of f, you draw the graph of 4 over x minus 1 with the hole at the point where x is 3. So we got f of x to be this. So then if we look at the limit of f of x as x goes to 3, we see that the limit would be 2. And so the limit of f of x at 3 exists. It is not infinity or negative infinity. So therefore f doesn't have a vertical asymptote at 3. On the other hand, so f doesn't have a vertical asymptote at 3, which I explained in the previous slide as well. if f of x is 4 over x minus 1, then now if I take the limit of f as x goes to 1 from the left, so notice that we know that this guy will have a vertical asymptote. This is in reduced form and the denominator vanishes at 1, so we know that we have a vertical asymptote at 1. However, I still want to know what's the behavior of the function on the left and right side of 1. So as x goes to 1 from the left, what can I say about f of x? Does it become large without bound, or does it become negative large without bound? Well, does it increase without bound, or does it decrease without bound? Well, the way we can tell that is the following. Okay, so as x goes to 1, the numerator goes to 4, obviously, and the denominator goes to 0, obviously. But notice that as x goes to 1 from the left, so then x is less than 1, then x minus 1 would be negative, right? So when x is close to 1 on the left side of 1, x minus 1 is negative and close to 0. So the entire ratio, when x is close to 1 on the left side of 1, the ratio here, 4 over x minus 1, would be negative. And since the denominator goes to 0, we're going to get that this limit is negative infinity. On the other hand, when x goes to 1 from the right hand side, then this fraction would be positive, because now x is bigger than 1. So this fraction would be positive, but the denominator still goes to 0, so this is going to go to positive infinity. Again, that's because we are dividing 4 by numbers that are getting closer and closer to 0, and numbers like 10 to the negative 80, 10 to the negative 900, and so on. So if you divide 4 by something like 10 to the negative 80, you're getting a huge number here. So that is, you can make this fraction as big as you like simply by choosing x close enough to 1 on the right side of 1. So we see that f does have a vertical asymptote when x is 1. So the line x is equal to 1 is a vertical asymptote here. So here is the graph of f. Now notice that this graph is in fact the graph of this function 4 over x minus 1. The graph of 4 over x minus 1 is this graph. The graph of f only differs from that by putting a hole at the number 3. So remember, this function is undefined at 3, but we were able to cancel out the factor x minus 3. So that means that the graph of f is the same as the graph of 4 over x minus 1 as long as x is not 3. Now the vertical asymptote is at 1, there is no vertical asymptote at 3, there is a hole at 3, and note the missing point at 3 too, because that's where the hole is. The calculator doesn't show this hole when you draw it. Okay, so I will stop the video here, and in the next video we'll be looking at another example. See you then.